In this section of the workshop, we will explore methods of increasing your students' engagement with the material in the classroom. One of the ways of doing this is through active learning. When we were learning, many of us sat in classrooms where a learned faculty member imparted their vast knowledge via spoken word, and we frantically wrote it down. When we begin as new teachers, the temptation is to copy this sage on the stage approach. Teaching in great centers of learning has been like this for thousands of years. Why change it? Because learning through lecturing doesn't work. Education research has shown that we retain only about 5% of what we hear in a lecture format. Other forms of passive learning aren't much better. We retain about 10% of what we read, 20% of what we passively watch, and 30% of a demonstration. How do we increase learning in the meager time we have with students? One method is through active learning. Active learning engages students with the material by having them discuss it, 50%, practice doing it, 75%, or teach it to others, 90%. The numbers I mentioned are the level of retention for these activities. In the last 15 years, active learning has begun to establish a foothold in higher education, but there are still those who resist. So what evidence is there that active learning actually works? In 2014, Scott Freeman and colleagues published a meta-analysis of 225 studies that compared active to passive learning in STEM classrooms. Here I present two figures from the article. Active learning decreases failure rates, moving them from 33% to 21%, the figure on the left. Additionally, active learning increases learning gains measured as Hedges G on average by 0.5 points. And this is across all disciplines in STEM that were looked at. This gain translates into an entire letter grade increase in student performance. The science is in. Active learning works. Period. End of story. However, for it to be effective, active learning must be a component of a well-designed course. The key here is a well-designed course. No amount of fancy presentations or inspiring activities is going to overcome a poorly thought out design. You need to start with your learning outcomes, imagine effective assessments, and then create activities that allow students to practice doing what your learning outcomes want them to do. As you create your design, you want to consider situational factors such as your audience, your course's curricular context, and how your course will be delivered. Finally, you want to continually check your alignment to ensure that what you teach and what you assess match your learning goals. So you are convinced you're going to use backwards design, fair assessments, and active learning. How do I get this started? Many people, when they first start doing this, are overwhelmed. Let me tell you a bit of data that will put your mind at ease. If you move 100% lecture class to 90% lecture and 10% active learning, you still get most of the benefits of active learning, and we'll see an increase in learning gains. Even a small change, such as a lecture pause, where you basically just allow students to stop for 2 minutes and catch up and organize their thoughts and notes, has a measurable positive effect. So dive in, the water's fine. Here I list some of the most common active learning strategies. They are lecture pause, think, pair, share, clicker questions response systems, group discussion, background knowledge probe, misconception preconception check, brainstorming, directed paraphrase, 1-minute paper, muddiest point, 1-sentence summary, and concept maps. Please see your handout for explanations because I'm not going to take a lot of time here and explain every single one of these. You can read about them. In the next few slides, I describe some of the methods I use most often. Response systems. First of all, let me say a little bit about the class I teach. I teach a large lecture format class, Microbiology 303, that will have anywhere from 200 to 300 students in it. Now, I also teach lab classes, but this is the one that I'm going to use as example here, Microbiology 303. Response systems such as Top Hat, which by the way UW-Madison has a license, are useful tools for getting any size group of students engaged with the material or each other. You pose a question and students use an electronic device, phone, computer, or a specific device to answer the question. Questions can be multiple choice, number ranges, short answers, and others. And this is expanding all the time as software develops. After they have answered the question, a discussion of responses often helps students to understand, especially if you go walk through the thinking that is used to answer the question. You can also use this as a stepping off point for a discussion on the material. Response systems are an excellent tool to monitor student thinking. They also allow everyone to participate. I am showing an example of a question in my module on gene regulation. Students often struggle with this material, having a hard time understanding each regulatory circuit that we go through. Response system questions give them a chance to practice with each regulation topic and increase their understanding. And in fact, the teaching that I do in this section is basically a flipped classroom where we just go through questions and they practice understanding the material while I'm there to clear up any misconceptions. Another common method I use in my large lecture class is think, pair, share. Students are asked a question related to the material and then asked to first think about it independently. After a short period, minutes, they share their answer with their neighbor. Finally, we share a few answers with the group. Think, pair, share requires the students to think for themselves, then articulate their idea to someone else. This recycling through working memory and reformulating in their own words so that someone else can understand them is a very effective way to learn. Again, this will give you a 90% retention rate. Shown here is an example think, pair, share I use in my section on metabolism. I try and relate this material to real world situations. So here we're talking about what would happen in a Wisconsin dairy if you're having problems and you see gas bubbles. And this question relates this problem back to metabolism that they've just been learning. In large classes, sharing out to the entire class can be intimidating. I mitigate this by first having students work together. Second, I often check on students as they work through the activity and find those that have excellent answers. I tell them they have a great answer and ask them if they are willing to share it with the group. This technique takes away the fear of being incorrect in front of the whole class and prevents me from terrorizing shy students if they just don't want to respond. One final example I will give you in this video is the minute paper. Ask students to write short, honest 3 to 5 minute answers to each of 1 to 2 questions on an index card or a paper questionnaire. They can be very general questions, such as the end of class asking students what was the most important thing you learned during this class, or what important questions remain unanswered. Minute papers can also be very specific, asking them to explain an important concept that you covered in this class or previous class. An example here is in my section on immunology, I will ask students to compare macrophages to neutrophils. What do they have in common and how are they different? And I find this is a very good learning technique, is to compare and contrast different parts of information that we're learning, and it helps them to recall how they're different and then analyze them. When you use this idea, make sure you give students plenty of time to write their answers. Getting started with active learning doesn't have to be daunting. A good place to start is by using a learning framework such as the one shown here. After you begin the class, you have 3 10 to 15 minute mini lectures where you explain material for your course and set up the activity, and then you do a 3 to 4 minute discussion on one of your learning outcomes. After the discussion, there's a second mini lecture block, followed by another discussion, etc., etc. A second way you can organize your course is using a clock. You map out how long each section of the class was going to be it brainstorm, lecture, data interpretation, case study, think, pair, share, etc. This map, right? And so you map out all the different activities that you're going to do. I will warn you that this map shown here is ambitious with 5 learning activities. My advice when you begin active learning is to start small and build. Remember that teaching is an iterative process, and you will always be striving for improvement, and you can add things and change things as you go. No good presentation ends without some homework. Aren't you thrilled? Now you know how your students feel. For our synchronous time together, I want you to pick a lecture you are working on, and then a part of that lecture, something that you want the students to do to learn the material. Pick a concept you really care about, and then take your best shot at writing a learning outcome. And again, remember, this is the first step of backwards design. You write your learning outcomes. When you write this learning outcome, use Bloom's taxonomy at the level of application or higher. So apply, analyze, evaluate, or create. Review your packet as needed to try and get a good learning outcome. Please do this before our synchronous session. When we get together, I will have you discuss your learning outcome with a partner, imagine an example assessment for that learning activity, and then create an activity that addresses that learning outcome. Make sure your learning outcome is actionable. It should be something that the students have to do, applying, analyze, evaluating, or creating. I look forward to seeing you in the Ethernets.